Welcome back. In this video tutorial, we will talking about drinking water purification and various methods used for the purification of water. Water is the elixir of life, so we need to purify the water. Purification of water. Purification of water is essential before its consumption so that the disease cycle of pathogenic microorganisms can be broken. Purification results in prevention of pathogen to reach the human body. So the water purification is done to make it a satisfactory appearance, taste, odor and free from pathogens. There are 6 methods used for the purification of drinking water. And this purification method depend upon the amount of water and characteristics of the water. The methods are screening, aeration, sedimentation, flocculation, filtration and disinfection. This image shows the drinking water purification procedure. Okay. Drinking water purification method starts with screening. Screening is done to remove the floating impurities from the water sample. In this process, core screen with pore size 75 mm or main with 5 to 20 mm are used to screen the water. Usually, the screen is slowly rotated to prevent the overloading. Okay. So, the screening can remove the floating impurities from the water. Second step, aeration. Aeration of the water helps to increase the oxygen content. It is very important. And the aeration also reduces the carbon dioxide content and it can remove methane, hydrogen sulfide and other volatile organic compound that is responsible for the taste and color. Okay. High iron content and manganese content in the water provide bitter taste to the water. That's a problem. So during the aeration process, the oxygen is brought into the water, which convert the dissolved ferrous and manganese compound into insoluble manganese and ferric hydroxide. This insoluble manganese and ferric hydroxide can be removed by sedimentation or filtration procedure. Okay. Third step in the drinking water purification is the sedimentation. Sedimentation is done when the water consists of large sized materials like leaves and gravels. The suspended particles settle down depending on their size and weight. Okay. This sedimentation is due to the gravitational force. Sedimentation is done in large reservoirs. The rate of sedimentation is enhanced by adding coagulants. Example, alum, iron, salt, etc. The sedimentation can provide the reduction of microorganisms, but it does not sterilize the polluted water. Sedimentation provides the partial reduction of microorganisms from the water. Next is the flocculation. It is a method of Drinking water purification. This method can remove microorganisms, organic matter, and toxic contaminants from the water. In this process, the water is collected in a large reservoir and it allows settling for a sufficient time. After the settling process, the material is removed and then the water is treated with flocculants. Examples for the flocculants are aluminum sulfate, alum, sodium aluminate, calcium, and colloidal silicate. This undergo precipitation and carry most of microorganisms from the water. In this way, most substances that impart turbidity to the water get coagulated. After the sedimentation process, the water is subjected to filtration to remove the microorganism. The process of filtration is highly critical and important, and it can remove about 99% of bacteria from the water. So, it is an effective method of removal of microorganisms and other suspended materials from the water. There are two types of sand filters are used in water purification. First one, slow sand filter, and second one, rapid sand filter. First filtration method, slow sand filtration. It is a slow process and it requires large area. This plant consists of a concrete floor containing drainage tiles. Drainage tile is for collection of filtered water. Then the drainage tile is covered with gravel and then sand. The water is passed slowly through the filter and collected by drainage tiles, which is pumped into a reservoir. If the water is turbid, slow sand filters are clogged soon. So, the turbid water which is to be filtered should be clarified first by sedimentation, thereafter passed through the slow sand filter. In the surface of layers of the fine sand, a colloidal material consisting of bacteria, algae, and protozoa is attached. Okay. Here you can see the picture of slow sand filter. Plant contains a concrete floor and this concrete floor contains drainage tiles. Okay, and the tile is covered with the gravels. Above the gravels it is covered with sand. Then the water is added above the sand and gravel. Then the water moves through the sand and gravel, and finally the filtered water can be collected through the drainage tiles. Second method is the rapid sand filter. It is similar to the slow sand filter, and the plant consists of layers of sand, gravel, and rock. First, the water is treated with alum or ferrous sulfate in a settling tank where precipitation done. This water is allowed to pass through a rapid sand filter. clogging is a problem of rapid sand filter. So it is cleaned by forcing cleaned water backward. Okay, the clogging can be prevented by passing cleaned water backward, that is backwashing through the beds of gravels and sands without disturbing the fine sand. Okay, and about 99% of bacteria are removed by this plant. So it is an effective method of purification. Rapid sand filter plant operates about 50 times faster than the slow sand filter. Disinfection. It is the last step in the water purification process. Only this process can ensure the absence of microorganisms in the water. There are two disinfection methods: physical disinfection and chemical disinfection. In the physical method, electromagnetic radiations of the ultraviolet rays are used, and its wavelength is about 250 to 260 nanometer. It is a highly efficient method and it is most commonly used method. The ultraviolet rays can destroy most of the microorganisms present in the water supply, and it does not causes any chemical effect to the water. That is, it does not cause any problem to the water, but produces a slight increases in the temperature of the treated water. Second method is the chemical method. Various chemical agents are used for the disinfection of the drinking water, that are chlorine, chlorine compounds, ozone, potassium permanganate, halogens, etc. Chlorine compound like calcium hypochlorite are commonly used for the disinfection of water. The chlorine gas is added to the water. About 0.2 to 2 milligram per liter concentration is sufficient to kill most of the microorganisms in the water. The chlorine added to the water reacts with water and forms hypochlorous acid. This hypochlorous acid have antimicrobial activity, so it can kill most of the microorganisms. Second chemical method is the ozone method. Ozone is a powerful oxidizing agent and it has rapid effect than the chlorine. It can destroy bacteria and virus. It does not produce any color and taste to the water. This is about drinking water purification. I think you got an idea about different methods used for the drinking water purification. Okay, thank you.